Hello, and welcome to Multiply Fractions by Whole Numbers Using Models for 4th grade. I'm Shanna Uwe.
And I'm Emily DeVizio.
So your first task is to pause the video, and you're going to complete the task on your own or with a team or partner. Solve for the expressions below. You have 4 groups of 1/2 and 1/2 groups of 4. Draw a model and record the equation that represents each expression. As you're thinking through the task, think about how they compare. Why is it important to begin multiplication of fractions by whole numbers with unit fractions? And what connections can be made between whole number and fraction multiplication and whole number multiplication? So here's the progression with Bess. In 3rd grade, they spent time representing and interpreting unit fractions. They represented and interpreted fractions and fractions greater than 1 using models, standard form, numeral form, word form. In 4th grade, we're adding and subtracting fractions with like denominators, including mixed numbers and fractions greater than 1. We're exploring how to multiply a fraction and a whole number and connecting that to whole number multiplication. And then using fraction models, number lines, and commutative property to multiply a fraction and a whole number. We're also solving real-world problems involving that. In 5th grade, we're multiplying a fraction by a fraction less than 1 or a fraction greater than 1. We're explaining the relative size of the products of 2 fractions that we multiply, and then also exploring how to divide a unit fraction by a whole number and a whole number by a unit fraction. For this video, we're going to explore how to multiply a fraction and a whole number, and then also multiply a whole number and a fraction.
That's a lot.
Yeah.
So I might even need to pause this just to kind of process where they're coming to me from and then where I'm taking them to.
Yep.
Woo, okay.
We want to start by modeling multiplying whole numbers by unit fractions. And when we do this, we really want to focus on making connections back to whole number multiplication. If I know 5 groups of 4 is 20, I can use that to help me figure out 5 groups of 1/4 is 5/4 or 1 1/4, and I can model them similarly.
I think saying it that way is easier to visualize for myself and even for my students.
Yep, we shouldn't hear times, we should say of, right?
Groups of, yep.
And then once again, connecting those models. Whenever I modeled 5 groups of 4 to get 20, I had 5 equal groups with 4 in each group, and I could use that repeated addition to help me. Well, I can do the same thing with fractions. If you look at the models on the right, I have 5 groups of 1/4 in an area model, and also 5 groups of 1/4 on a number line. Or I can add 1/4 5 times to find that answer. So the more we can connect it back to whole number multiplication, the better off you're going to be.
Helps support understanding because it makes sense.
So now we're moving to modeling multiplying whole numbers by fractions. So no longer just a unit fraction, but we can still make connections back to that. Now I'm multiplying 5 groups of 3/4. So I want to use that same language again. If you look at the number line on the bottom, you can see I have 5 jumps or 5 groups, and there's 3/4 in each group. So I can also use that repeated addition or just the multiplication to make that connection back. And then on the left, you can see 2 groups of 2/5. Well, I have 2/5 in the first group, 2/5 in the second group, and if I combine them, I get 4/5. So once again, make connections back to whole number multiplication and also multiplication of unit fractions.
I like that you start with the unit fractions and then build upon that by any fraction.
So now we're moving to modeling multiplying fractions by whole numbers. So we're changing the order of those factors. So I'm no longer multiplying a whole number by a fraction by a whole number. So I have 1/2 times 6 or 1/2 of 6. We want to use that same language. If you look on the bottom left model, you can see I have 6 wholes and I'm finding half of each whole. So how many are shaded? Well, 6 halves or 3 wholes. Or you can see I'm moving away from unit fractions and into just fractions by a whole number. And I have 2/3 of 6, which gives me 12/3 or 4 wholes.
Wow, this is very abstract. I know that when I'm multiplying a whole number by a fraction, it's a lot easier for me to visually see 6 groups of 1/2, right? Yeah. And here I'm taking half groups of 6 wholes. So it's different, but I really like how the models help support that visually to build that understanding.
Definitely. So we're definitely wanting to utilize the commutative property in multiplication when we're multiplying a fraction and a whole number and a whole number and a fraction. They know from previous experiences that a product is going to be the same, but we want them to understand why that is using models. So we're going to look at 4 groups of 1/2. So you can see I have 4 wholes and I've shaded in 1/2 of each of those 4 holes.
Okay, I see that.
Yep. And then if I combine them, I can see easily that there's 2 holes. So now I can finish my equation and see that 4 groups of 1/2 is 4 halves, or 2
Putting
holes.
those halves together forms or creates 2 holes.
Yep.
I think visually that's very important to actually manipulate and have the students model to see that.
Yep. So then I can flip those factors. So now instead of 4 groups of 1/2, I have 1/2 of 4. So here's my 4 holes. I can find 1/2 just by drawing a line and separating it. And I see that I have those 2 holes at the top. Or the other model could be I have 1/2 of 4 holes, right? And then I combine them to find that it's 2 holes.
Oh, okay.
So those models help deepen the understanding and put that rigor into the math of it. So we don't want to just assume that they've got it just because they understand the commutative property.
Or that they got the correct answer, right?
Yep.
And these are 2 very different models,
Yep.
which is important to point out. We do yield the same product, but it's a different model of representation.
And compare and contrast those models. The model might look the same at the end, but how did I get there?
And that's important to have that conversation, definitely.
So this is to kind of recap some of the strategies that we discussed. First, you would start with those concrete models to represent multiplying a fraction and a whole number and a whole number and a fraction. Then you're going to move to those representations like area models and number lines and drawings. And then abstract, you're going to record those equations. It could be repeated addition or just the multiplication equations to show the connections back to the models.
And then to remember too that we need to be fluid within these islands, right? So for some components, I may be at the abstract island, but I may need to go back to my manipulatives to solve a particular problem.
Yep.
And we want to encourage that so that our students build that understanding.
And the more connections back between the different strategies and the more connections back to whole number multiplication, the better off we're going to be.
And starting with unit fractions.
Yes.
So.
Thank you for joining us today to learn a little bit about multiplying fractions by whole numbers using models.
Have a great day.
Bye. See you next time.